Hello students, today I am going to discuss certain topics. First one is superconductors. Superconductors are conductors having zero resistance or zero resistivity. Okay, note it down. There are certain materials that show superconductivity at very low temperature, that is 0 Kelvin or minus 273 degrees Celsius. It means superconductivity is somehow related to temperature. To understand the connection between the superconductivity and the temperature, we have to understand how the resistance of a conductor changes with temperature. Since we know that the resistance of a conductor increases with temperature. Okay? As temperature increases, resistance of the conductor increases. And it is also true, when temperature of the conductor decreases, then resistance of the conductor also decreases. Okay. So there are certain materials for which when the temperature goes to or reduced to 0 Kelvin or minus 273 degrees Celsius, the resistance of those materials becomes 0. Okay. Then those materials are known as superconductors. Okay. Now the question is how the resistance of a material becomes 0. Okay. So to understand this, come to this picture. Now consider the two neighboring atoms in a conductor, atom 1, atom 2, at room temperature, that is 27 degrees Celsius or 300 Kelvin. Okay. At this temperature, the atoms of the conductor are in vibration. Okay. So this atom is vibrating to and fro in this range from here to here, and the second atom also vibrating, okay, to and fro in this range. Okay. Now this atom occupying this much space during vibration, and the second atom also occupying this much space during atom. And consider a free electron which is moving through the conductor and passing through the conductor in between these two atoms. Then for the free electron, this much free space is available. Okay, it means the free electrons encounter only this much space to pass through. So this space is known as free space. Okay, free space. Okay, so the free space is very small, very narrow, so the probability of collision is more. Okay, and you know that from the definition that the collision between the free electron and the atom offers opposing force, and this opposing force is known as resistance of the conductor. Okay, so now when the temperature decreases, means 27 degrees Celsius to minus 273 degrees Celsius, means 0 Kelvin, then the atoms cease to vibrate. Okay, the motion or the vibration of the atoms in the conductor stops completely. So at absolute temperature 0 Kelvin, the atoms stop vibrating. Okay, and now the free space between the atom is this much. Okay, and in this case, when the free electron is moving through the conductor between these two atoms, okay, then there will be no collision because there is a lot of free space for the free electron. And when there is no collision, means there will be no opposing force and no resistance. Okay, so which defines the resistance? The collision between the free electron and the atoms at any temperature. Okay, above this 0 Kelvin, at any temperature, the atoms are in vibration, and due to their vibration the free space between the atom reduces, and the probability of collision between the electron and the atom increases. Okay, when the collision number of collisions increases, the opposing force increases, and hence the resistance increases. Okay, so this is the concept behind the superconductivity. Okay, one of the most uh, important material that shows superconductivity is mercury. Okay. Mercury is mercury shows superconductivity. Write down. Mercury shows superconductivity at 4.2 Kelvin. At 4.2 Kelvin, mercury shows superconductivity. It means at 4.2 Kelvin, the atoms or ions of mercury, okay, cease to vibrate. Okay, there will be no vibrations of mercury atoms at 4.2 Kelvin. Okay, now application. What is the application of superconductors? Superconductors are widely used to produce strong magnets and fast switches for computing purpose, and also widely used in material science. Okay, and zero resistance means zero loss. Okay, so superconducting wires are used to transmit power with no loss from one end to another. Okay,